Hi everyone, welcome back to the AI language. So today we are building an MCP client that connects to an MCP server and uses the Gemini API to process natural language queries and execute tool commands. So guys, before we start, let me show you an amazing preview of what I was able to accomplish with this MCP client connecting to my MCP server. And it's pretty amazing that you can actually use a remote large language model, connect it to your MCP client and your server, and then you give queries to your MCP client to actually run all the commands using your server. So here goes the preview. So once you run the MCP client, you'll actually get the welcome message which says connected to server with tools, run commands. So this means that our client has been able to connect to the server and get the available tools, which is just one tool over here, which is the run command function, which we basically use to run commands on the terminal. And this output shows that we are in the chat loop and we can write a query. So let's ask Gemini to create a file for us and add some text to it. Alright, so I've asked it to create a file MCP client success.txt and add the text I successfully created an MCP client with the Gemini API and connected it to my MCP server. And let's see what Gemini does with this. Okay, so as you see in the result, Gemini requests a tool call, which is run command, and the arguments are echo I successfully created an MCP client with the Gemini API and connected it to my MCP server. And this is basically written to MCP client success.txt, which is the file name that we provided over here. So this works pretty well. And then this tool would be executed and the response from the execution sent back to Gemini, which it then reads and responds as I have successfully created the file and added the text which we had requested. So if I go to the Finder now, I can see that I have the MCP client success.txt file over here. And I can just double click to open this. And it says I successfully created an MCP client with the Gemini API and it connected it to my MCP server. Before we begin, if you enjoy learning about AI coding and automation, please like this video and subscribe to our channel on YouTube. You can visit it at youtube.com/@the-AI-language. Now let's get started. So for a quick recap, MCP servers, these are the folks over here. So these are the backends that expose external tools. For example, in our last video, we have built our own MCP server, and we built this as a Python-based MCP server that can run terminal commands on our MacBook, and we're going to use it this time. MCP clients are these folks over here. So these are the front ends that interact with the server, and they send queries to the large language model over here, and they process the responses, and then they can trigger and execute tool executions on the servers. So now why are we using Gemini and not Anthropic or any other model? Because you can actually go to aistudio.google.com and log in through your Gmail account, and they're going to give you a Gemini API key for free. So there are some terms and conditions that you can check when you take this key, and essentially you can actually use it for free for testing purposes with certain lower limits, and by allowing them to use your data while training their model. And this then makes it an ideal choice for this tutorial and experimentation. So today we'll build a client that will basically connect to our previously built Python-based MCP server. It will list the available tools like our terminal command executor, and it will send user queries to the Gemini API for processing, and it will execute any tool calls through MCP server and display the final response. Alright, so first let's set up our environment. So we need to create a new project and a virtual environment. Alright, so we go to the terminal. So you can open your terminal. So now we are in our home directory, and we can do a ls-l and see that we had created a MCP directory over here last time. You can create this directory if you have not got this, and then we change to this directory, and you can see that we have two folders over here. One is for the workspace where our server can run all the commands so that we don't spoil anything outside this workspace, and the other thing is the servers folder where we had created our folder. So now let's create a clients folder over here, and let's change to the clients folder. Alright, so now we'll use uv init MCP client to actually initialize our project. So this command creates a new project directory called MCP client using the UV command line interface CLI tool. Now let's change to this directory. This has changed our current working directory to the newly created MCP client folder, and now we'll create a virtual environment. So for that we do UV venv and press enter, and this basically is a virtual environment that will isolate all our project dependencies so that they don't conflict with our other projects. Now let's activate the virtual environment by typing source.venv/bin/activate. Activating the virtual environment ensures that Python uses the correct dependencies for this project. Alright guys, so now we're going to install the required packages, and one thing that we're going to install is the Google Gen AI SDK for Python. How you do that is using pip install Google Gen AI. We're going to do UV add Google Gen AI because we are using UV as a package manager. And the other two are the Python environment variables package python.env and the MCP library as well. So what to do that, what we do is we say UV add MCP, then python -.env, and then we add Google Gen AI, and we can make sure that we have matched the name correctly over here, and then press enter. And I've already added MCP during the last tutorial on setting up MCP servers. I've already added python.env as well and Google Gen AI, so it does that very fast for me. You can actually install it by typing this command. Alright guys, so next thing that we're going to try and do is to get our Gemini API key. So I'm on aistudio.google.com, and when I visit this site, it automatically gives me a prompt to get an API key over here. And otherwise, I think there's a button over here also to get the API key. So I'm just going to click on get API key over here. Okay, so there's a code to test the Gemini API, and there's a create API key button over here. So let me just use the API key from here. It's going to now generate the API key for me. And you should use your API keys securely and not share them or embed them in code that the public can view. I'm going to disable this after the tutorial. For now, I'm just going to copy it from here and let it be visible. So to store our API keys securely, what we can do is we can go to the terminal and we can create a .env file. Then let's open that file in Nano. And then let's paste our API key over here. And then before that, we're going to write Gemini _API _key equal to. And let me add the I over here. And now this is basically an environment variable that I don't need to store in view in my code. And I can use this while developing my MCP client. Let's press Ctrl X and save the file. And what we'll also do is that we'll add this file to gitignore. To do that, write echo.env, which is the file name in double quotes. And then we write it to .gitignore. So this basically prevents accidentally sharing our API key on places like GitHub or any other remote repository. Alright, so now let's write the code for our client. So we'll use touch client.py, and this is going to create our Python file. And let's now open VS Code. So this is our server code from before. So what we'll do is we'll say file, new window. We'll go to file, open folder, and then go to MCP clients and MCP client, and we'll open this folder over here. Let me say I trust the authors, and let's open our client.py file. Alright, so this is the client.py code, and we'll go through it step by step. You can check this out using the GitHub repo link that's given in the description and in the pinned comment. So first of all, on the top, we have all the necessary libraries like async IO, OS, sys, and JSON. And these are used for async operations, environment variables, and system specific parameters and functions, and for handling JSON data. Alright, so next we import the MCP client components, and this basically allows us to interact with external tools and execute commands like the MCP server. We use client session to manage our connection to an MCP server. We use stdio server parameters to define how we connect, and we use stdio client to establish communication. And now we import Google's Gemini AI library and some helper types for function calling. So Gen AI is basically the main client for interacting with Gemini AI. Types helps us structure our AI generated responses, and load.env loads our API keys securely. Next, we load our .env file so our script can access the Gemini API key. This ensures that sensitive data like our API key is kept separate from this code and not exposed in the script. Okay, so now let's create our MCP Client Class. This will handle the connection to the MCP server and communicate with Gemini AI. This is the MCP session for communication, and this is going to manage our async resource cleanup. Then we have the Gemini API key that we store in this variable and check for its value over here for any errors. And then we configure the Gemini AI client by providing it with the Gemini API key. So this MCP client class basically manages everything from connecting to the MCP server to sending queries to Gemini. Inside the constructor, we retrieve our API key and configure the Gemini AI client. So next we define the connect to server function, and this is the method that basically connects to the MCP server and will list all the available tools that are available with the server. It basically takes in the server script path, and if you recall from the last video, we had created a terminal_server.py script for the terminal server, and that's basically what it will take over here. Now based on the extension of this script file, we might have a server written in Python or in JavaScript. So basically we want to determine whether the server script is written in Python or JS, and this allows us to execute the correct command to start the MCP server. So in our case, the script path ends with py, so we are going to take Python as the command. Then we define the parameters for connecting to the MCP server, which is basically the command and the server script path. And then we establish communication with the MCP server using stdio over here. And finally, we are going to extract from the transport object the read and write streams for the server. Then we initialize the MCP client session over here, which allows interaction with the server. And then we are going to send an initialization request to the MCP server. Finally, we request the list of tools from the session from the MCP server, and we will save it in the tools variable over here, and then print a message for the user that we're connected to the server with these tools, which is the tool names. In our case, for the terminal server, this is going to be the run command tool, which will allow us to run commands on the terminal. Now, MCP tools which are received from the server are basically in a certain format that we need to convert to a different format so that we can actually pass it to Gemini. And that is what we do using convert MCP tools to Gemini format, this function over here. So let's have a quick look at what this function does. So we have the function defined over here, convert MCP tools to Gemini, and it basically converts MCP tool definitions to the correct format for the Gemini API function calling. This basically takes in MCP tools as a list, which is basically a list of MCP tool objects with name, description, and input schema. And it returns the list of Gemini tool objects with properly formatted function declarations. So we initialize a blank Gemini tools, and for each tool in MCP tools, we basically first run a clean schema function on the tool.input schema, and this is basically going to remove some parameters which are forbidden for Gemini, which basically Gemini doesn't expect. And if you want to look at the clean schema function, we can go up over here, and this is the first step. So what we do is that if it's a dictionary, we will basically remove the title if that is present inside it. And then we check if there's any nested properties, which is also a dictionary. Then for each key in that properties, we are going to again run the clean schema command. So this is basically removing title over here. And I did this because when I tried it with the title, I got an error which said that this title is basically forbidden inside this schema. So that is the clean schema part. So for each tool, we'll first clean the schema. Just to clarify, function declaration and tool are both imported from google.genai.type. So these are basically what Google defines for proper function calling in Google's Gen AI SDK. And over here, while converting MCP tools to Gemini, once we have cleaned the schema, we basically use function declaration and tool, which are both provided by Google's Gen AI SDK. And we first define a function declaration, which basically takes the name, description, and parameters and provides us with a function declaration object. And then we create a tool object using these function declarations, and then we append it to a list of Gemini tools, and then we return that Gemini tools list. That is what the convert MCP tools to Gemini does. In case you are going to use some other large language model, you might have to convert the tools returned from the MCP server to a proper format which is expected by that particular large language model to implement function calling, because all these models might implement function calling in a different way. Alright, so let's go back to our connect to server function. Alright, so here's our connect to server function, and we were on the last line, and now we basically have defined the function declarations for our MCP client class. So next, let's move to the process query function, and this basically processes the user query using Gemini's API, and it will also execute tool calls if that is what is returned in the response from the large language model API. And the arguments are basically a string query, which is the user's input query, and it will return the response generated by the Gemini model. Next, we'll format the user input as a structured content object for Gemini, and basically we define the role as a user, and we basically define the part of it, which is basically the query from the user, and get the user prompt content. So this is one part of the content that we'll use. Next, we send the user input to Gemini AI, and we'll include all the available tools for function calling over here. So we're basically asking Gemini AI to generate content. We are defining the model as Gemini 2.0 Flash 001. And we are defining the contents as the user prompt content, which we basically defined over here. For the config, we basically provide the tools. Then we store the response in the response variable over here. So then we have these two variables, final text, which is going to store the final formatted response, and the assistant message content, which is going to store the assistant response. And we're just initializing these two variables over here. And this is where we basically process the response received from Gemini. So again, this basically depends upon the response format that Gemini uses. So we basically process each candidate in the response, and then each candidate has content parts, and then for each part we will check if the part is a valid Gemini response unit, and if it's a function call. So this basically means that Gemini is suggesting a function to be called, so we want to process that. So we'll extract the function call details. So we'll store the function call response in something called function call part. This is a variable, and we'll get the name and the arguments that Gemini requested for the function call as tool name and tool arguments. And then we'll just tell the user that Gemini has requested a tool call, and then we're going to execute the tool using the MCP server. So we'll call the MCP tool with the arguments. So we'll provide the tool name and the tool arguments, and we're using the session over here that we defined early on. And then we'll await the response and store it as a result, and then we'll basically get the function response as result.content. If there's an error, then we store the error. Now again, we need to format this response of the tool call to a way that Gemini understands, right? So we basically create something called a function response part using types again, and we provide the tool name and we provide the response over here. Then we structure the tool response as a content object for Gemini over here, and we send this tool execution result back to Gemini for processing. So it knows what has happened over there in the tool call. So over here we again provide the model, but now for contents we provide the user prompt content which we provided for the first time. Then we include the Gemini's function call request, and finally we provide the tool execution result. So now Gemini has a complete context of what transpired, and we again pass the tools as well so that it can use it for continued use. Finally we get the response over here, and then we extract the final response text from Gemini after processing the tool call, and this is what is appended to final text over here. And finally we return all the parts of the final text separated by a new line character, and this basically completes our process query function. Alright, so then we have two more functions. One is the chat loop. So this is basically going to run a loop which expects a query from the user, and it's basically going to process the query and get a response and print that response out, and this uses our process query function. We also have a cleanup function which basically cleans up the resources before it exits the program. And then we basically go to our main function over here. The main function basically initializes the MCP client and then connects to the server using the connect to server function that we went over. It then initiates the chat loop, expecting queries and processing all the queries from the user. And once the user basically types quit, it basically then quits the chat loop and breaks out of it. And finally, we run the cleanup and then exit the program. So this basically completes the entire client.py file that we had. And now you can actually go to the terminal. At the terminal, you can write uv run client.py and then provide the path to the server. Based on our directory structure, it's the parent directory twice, and then the servers directory, and then the terminal server directory, and then the terminal server.py file. So we have provided the terminal server py path over here, and we can press enter to run this. So once you run the MCP client, you'll actually get the welcome message which says connected to server with tools run command. So this means that our client has been able to connect to the server and get the available tools, which is just one tool over here, which is the run command function, which we basically use to run commands on the terminal. And this output shows that we are in the chat loop and we can write a query. So let's ask Gemini to create a file for us and add some text to it. Alright, so I've asked it to create a file MCP client success.txt and add the text I successfully created an MCP client with the Gemini API and connected it to my MCP server. And let's see what Gemini does with this. Okay, so as you see in the result, Gemini requests a tool call, which is run command, and the arguments are echo I successfully created an MCP client with the Gemini API and connected it to my MCP server. And this is basically written to MCP client success.txt, which is the file name that we provided over here. So this works pretty well. And then this tool would be executed and the response from the execution sent back to Gemini, which it then reads and responds as I have successfully created the file and added the text which we had requested. So if I go to the Finder now, I can see that I have the MCP client success.txt file over here. And I can just double click to open this. And it says I successfully created an MCP client with the Gemini API and it connected it to my MCP server. So isn't this amazing, guys, that we have created our own MCP client today and we have connected to our MCP server. The MCP client actually runs with a large language model that's actually not local, it's on a remote Google Cloud, and it uses the Gemini API to connect to the Gemini model. The Gemini model can actually receive the user query, understand what tools are available on the server, then request tool calls, and our client then actually passes that to the server, runs the commands that we need locally on a computer, and gets the result and then sends it back to Gemini, which then responds with the final response message over here. So we can quit by typing quit and press enter, and then we have exited the MCP client. So that's all for this particular video, and what you can do is you can actually go to GitHub and get the entire code and try it out yourself. The best part about this tutorial is that you don't have to spend a dime, and you can actually run this for free and test it out yourself. Thanks for watching. Please do subscribe to my channel and like this video, and I'll see you in the next video.